It's 2 in the morning in Croton, Ontario, and something is moving through a cornfield that shouldn't be moving at all. Nobody sees it happen. That's the thing about a tornado at 2 a.m. in a town of a few hundred people. There's no audience, just rain, then wind that doesn't sound like wind, then a farm-out building losing its roof in the space of a few seconds. By the time the sun came up, there was a path. 4.8 kilometers of it cut straight through young corn, 150 meters wide, trees down in clusters that didn't look like ordinary wind damage. A shape pressed into the field that researchers can read like a fingerprint, left in a place nobody was watching. 2 weeks later, the Northern Tornadoes Project confirmed it. An EF-EF-Erie tornado winds up to 130 kilometers an hour. On paper, that's the weakest rating a tornado can get. In the field, it was strong enough to do all of that without a single person there to call it in. Croton wasn't alone that night. 20 minutes before the tornado touched down, a downburst hit Walpole Island, strong enough to fold a communications tower in half and knock out power for thousands of people across Chatham-Kent. 20 minutes after, a second downburst tore through Blenheim, peeling shingles off houses and dropping trees across yards a town over. 3 confirmed wind events, 1 storm, 40 minutes start to finish. If you live in southwestern Ontario, none of this made the news outside the region. A weak tornado, 2 downbursts, no injuries. The kind of night that gets a paragraph in a local paper and nothing more. Except this storm wasn't the first one this season. It was the 4th. Go back to May 9. A storm near Lucan tips over a solar panel and tears the roof off a barn. Nobody gets hurt. It's Ontario's first confirmed tornado of the year, and almost nobody outside the area hears about it. 10 days later, 2 more touchdown on the same evening, both near London. One flips a semi-truck on its side. The other cuts a path from Lambeth to Mossley with enough force to be rated EF1, a full step up from the others. That same night, a downburst tears through East London at 145 kilometers an hour, fast enough that researchers spent days deciding whether it had even been a tornado at all. And somewhere in that same stretch of weather, near Huntsville, a person dies. Then Croton. Then Walpole Island and Blenheim. By the second week of June, the count sits at 4 confirmed tornadoes and 3 confirmed downbursts, and the season isn't even at its usual peak yet. Numbers don't shake, people do. Sue Rommel was in her backyard in London on May the 19th when the sky went white. I ran up to see, and it was like white, you couldn't see the fence, she said afterward. Then the fence itself started moving, flexing in and out like something was leaning on it from the other side. Then the trees came down. A few streets over, a falling tree pulled a power line down onto Kevin and Carol Landry's car. Nobody was inside it. That's the only reason this is a story about a dented hood and not something worse. The same kind of near miss playing out across 2 counties that same week. Near Huntsville, the luck ran out. This is what 4 tornadoes and 3 downbursts actually mean underneath the EF ratings and the kilometre counts. It means a specific fence and a specific backyard, a specific car under a specific power line. A death that Environment Canada filed under severe thunderstorm activity, because that's the only category that existed for it. Nobody in Ontario grew up expecting this. That's not a feeling. It's a fact about how the warning systems, the insurance policies, and the building codes here were built. For a province that saw this once a decade, not 4 times in 6 weeks. David Sills has a strange job. When a field gets flattened, somebody has to decide what did it. If we're looking at a really wide path, a kilometre or more, it's typically a downburst, he said. Tornadoes usually have a narrower path. There's another tell too. whether the damage happened in dry air or while rain was falling, and how long it lasted. A downburst can grind on for a minute or two. A tornado is usually over in 10 seconds. To see why an EFD and an EF3 aren't really the same kind of event, look at what happened 3 days before Croton, on the other side of the country. On June 9, a tornado tore across farmland near Oxbow, Saskatchewan, with peak winds estimated at 245 kilometres an hour, more than twice what hit Croton. It tracked 32 kilometres, half a kilometre wide at its strongest, and drove straight through a farmstead. NTP rated it EF3, Saskatchewan's first tornado that strong since 2010, and the most powerful anywhere in Canada since an EF4 tore through Didsbury, Alberta in 2023. Sills put the rarity in plain numbers. About 99% of Canadian tornadoes rate EF2 or weaker. Only 1 in 100 reaches EF3 or higher. Croton's tornado was an EFD, Oxbow's was an EF3. Both get called a tornado. Only one of them takes the roof off a barn. The other one takes the barn. That's the job behind every one of those EF ratings. It isn't a guess. It's a forensic reconstruction pieced together days later from something that happened in pitch dark and lasted about 10 seconds. So here's the actual question. Nobody's answered yet. Why is there suddenly this much to reconstruct? Part of the answer is happening 2,000 kilometres south. Tornado activity in North America has been drifting east for years, away from the classic Plains corridor and toward the Great Lakes Basin, into places like Illinois, Mississippi and Alabama that used to be edge cases and are now becoming the new centre. Meteorologists tie it to a jet stream sitting in a different position than it used to, and Gulf of Mexico moisture riding further north than the old averages expected. The second part is closer to home. This year, La Niña is exiting fast, and when that happens, the atmosphere becomes more willing to lock into the kind of setup that produces exactly this: repeated rounds of severe storms instead of one big season and then quiet. There's an obvious objection to all of this, and it deserves an honest answer instead of getting waved away. Canada spent decades undercounting its own tornadoes. Nobody was out there checking remote fields and forests the way they are now. In late 2025, the Northern Tornadoes Project started using an AI tool specifically built to spot tornado damage in places too remote for a survey team to drive to. So some of this rise in numbers isn't the atmosphere doing something new. It's researchers finally counting what was always happening, quietly, in places nobody was looking. That's a real complication, and it cuts against the drama of this video in a way worth sitting with for a second. But it doesn't explain all 4 of the season's tornadoes. Lucan, Christina, Lambeth to Mosley, and Croton weren't found buried in satellite imagery years later. They were confirmed within days, in populated farming country, by a team responding to storms everyone already knew had happened. Better counting explains why Canada's historical tornado total keeps climbing. It doesn't explain why this particular season, in this particular stretch of farmland, produced this many confirmed events before the season has even peaked. Here's what nobody can tell you yet: whether Ontario is actually inside that eastward shift, or just having an unlucky season that looks like one from the outside. The research connecting the Great Lakes drift to specific Canadian provinces hasn't been published, not because nobody's looking, because 4 tornadoes in 6 weeks is exactly the kind of season that gets that paper written, and right now we're living inside the data before anyone's had the chance to analyse it. Here's the part that doesn't show up in any of the NTP reports. The tornado warning on May 19 went out less than 20 minutes before anything touched down. That's less a failure of the system than a hard physical limit. 20 minutes is close to the ceiling of what's possible, given how fast these storms organise. And that's not a comfortable thing to hear, but it's the true one. Insurance policies in this province are priced around storms that happen once or twice a decade, not 4 times in 6 weeks. Building codes for rural outbuildings, the kind that lost its roof in Croton, don't assume wind loads like this as a regular event. None of that is anyone's fault. It's just math that was done for a version of Ontario that may not be the one that exists anymore. And this isn't a new ceiling. In 1985, an EF4 tornado tore through Barrie. 8 people died, 155 were hurt. That happened decades before anyone was talking about shifting jet streams or a fading La Niña. Ontario has always been capable of producing something far worse than an EFD in a cornfield. What's different now isn't the ceiling. It's how often the province is brushing up against it. Sue Rammel's fence, the Landrys' car, the person who didn't make it through that same stretch of weather near Huntsville. None of that happened in a freak year. It happened in a normal one, by the numbers this season is setting. 4 tornadoes, 3 downbursts, before July. So the honest question isn't whether Ontario can survive a tornado. Barrie answered that badly 40 years ago. The question is whether anything built since then accounts for this many chances to find out again. There's no clean ending here, and pretending otherwise would be the dishonest part. Nobody is going to publish a paper next week proving Ontario sits inside whatever's pulling tornado activity toward the Great Lakes. That proof, if it comes the slow way, another season like this one, then another, until 4 tornadoes in 6 weeks stops looking like an anomaly and starts looking like the new normal nobody named in time. Until then, there's just the count. It sat at 1 or 2 confirmed tornadoes a year for most of the decade. This season, with summer barely underway, it's already at 4. The 5th one is coming at some point. Maybe this year, maybe next. Nobody will know it's the 5th until the survey team finishes counting, days after it's already happened. That's not a flaw in the science. It's just what it means to live somewhere the data hasn't caught up to yet. Whoever's standing under it won't get a warning that says so. Ontario's tornado season historically peaks later in the summer, not in May and June. Whatever produced 4 confirmed tornadoes before the season even reached its usual high point is still out there, and it has more weeks left to work with than it's already used.